Hello, Year 7. Before we continue with our lesson on space, the first thing I'd like you to do is the Do It Now task. So you have 3 questions. 2 of them I expect all of you to have a go at, and the third question is a challenge. So if you want to challenge yourself, then you should be trying that question as well. So you can pause the video now and have a go at doing those questions. So, how did you get on with those questions? Question number 1 then. Why is it hotter in the summer than in the winter? So it is hotter because the days are longer. So that means that the sun has more time to warm up the earth for a longer period of time. And the rays of the sun are more concentrated than they are in winter. And they are hitting more directly as well. So we're receiving a lot more of the sun's energy that way. As for question number 2, what pattern links the distance a planet is from the sun and the time taken by the planet to orbit the sun? So the further away the planet from the sun, the greater the time taken to orbit the sun itself. So Neptune, for example, takes 164 years, which is the planet that is furthest from the sun. On the other hand, Mercury takes only 88 days to orbit the sun. So you can see a huge contrast and difference in the orbital times for the planets from one extreme to the other. The challenge was why is the shadow of the fence post longer in the winter than in the summer? And that is simply because the sun in the winter is lower in the sky, and so that makes the shadows a lot longer. So today's lesson is P4.3 from the Activate book. It is the unit about the Earth, and your learning objectives for today, we only have 2. The first one is that you need to be able to explain the motion of the sun, the stars, and the moon across the sky. And you should be able to explain why seasonal changes happen. Why do we have seasons on Earth? So now the Earth, it isn't just orbiting or revolving around the sun. It is also spinning or rotating on its own axis. Now the axis is an imaginary line that runs through the center of the Earth from the North Pole to the South Pole. And this rotation is taking place from west to east. Now it takes 24 hours or 1 day for the Earth to complete one entire rotation or one entire spin. Now one part of the Earth can face the sun at any given time. The part that faces the sun has obviously daylight, whilst the part that faces away from the sun will be facing its nighttime. It takes 365.25 days for the Earth to orbit the Sun. So every 4 years, whenever we have a leap year, there is an extra day in February when the year has 366 days to compensate for this extra quarter of a day that we have to orbit the Sun. As the Earth spins, half of it is in day and the other half is in night. Throughout the course of the year, the height of the sun, the average daily temperature, and the stars that we see in the night all change throughout the 4 seasons. So for example, in winter the sun is very low at noon, and in the summer it is very, very high in the sky at the same time. As the Earth travels around the sun, the North Pole is sometimes directed towards the sun, as we can see in this diagram over here, and sometimes it is directed away from it. So let's take a look at the case in this picture. When the North Pole is directed towards the sun's rays strike most directly on the northern hemisphere. The rays are said to be concentrated and spread over a very, very small and intense area, So the more directly the rays strike the Earth, the closer to the vertical they are. Vertical rays of sunlight are more effective in producing light and heat compared to slanting rays that we would normally get in the winter months, because slanting rays have to pass through much more thickness of the atmosphere, and they lose more heat as a result of this. And also, the heat is spread out over a greater area when the rays are slanting. So vertical rays are much more concentrated. So during the summer, the northern hemisphere receives a huge amount of sunlight. They have longer days. If you go up to the North Pole, the sun doesn't actually set at all, whereas in the South Pole at the same time, the sun never rises. And in the Southern Hemisphere, you have shorter days. Okay, whereas in the equatorial regions of the Earth, you have days that are approximately equal to the nights. Why do we have the seasons? It's all to do with the fact that the Earth is tilted a little bit. It's tilted at 23.4 degrees. This little tilt causes one part of the Earth to lean a little bit to the side, while another part of it is leaning away from the sun. This means different parts of our planet's surface get different amounts of sunlight and heat. At a certain time of the year during the Earth's orbit around the sun, the northern hemisphere leans towards the sun, and that happens in about June, as you can see from this diagram. At the same time, the southern hemisphere will be leaning away from the sun. Okay, at another time of the year, the southern hemisphere leans towards the sun, whilst the northern hemisphere leans away from the sun. And this happens in December, as you can see again on the diagram. This pattern, as a result of this 23.4 degrees tilt, creates the seasons. If the part of the world you're in is leaning towards the sun, it's warm and the days are long, so it's summer. And when you're in the part of the earth that's leaning away from the sun, the days are short, it's cold, and you're in the winter. Now, if we didn't have the axis tilted as it is, the sun would always be directly over the equator, and the northern and southern hemispheres would both have constant, similar weather all year round. If we look at this diagram, this is a diagram that's showing the angle of sunlight striking the Earth in the northern and southern hemispheres when the Earth's northern axis is tilted away from the sun. So in other words, when it is winter in the north and summer in the south. So we can see from this diagram that the sun's rays that are striking the northern hemisphere are striking it at a very shallow angle, and so the area across which these rays are striking the northern hemisphere are spread out over a much wider area, and so the weather is a lot colder, and also the days are shorter. In fact, the northern hemisphere, right at the North Pole, it's always dark, whereas in the southern hemisphere at the South Pole, it's always daytime. And you can see, looking at the southern hemisphere there, that the sun rays are striking much more directly, and so the heat and light are much more concentrated, and therefore we have summertime over there. So that would be in our December period of the year. Just to finish off this lesson on the Earth and the seasons, here we have a wonderful picture which is taken in the Arctic, so in the Northern Hemisphere, the North Pole, over 24 hours. So every hour there was a picture taken in the same place, looking at the sun. And as you can see, the sun dips quite a bit, but it never actually sets, it never gets dark. And this is the summertime in the Northern Hemisphere. Meanwhile, at the same time in the Southern Hemisphere, down at the South Pole, it's always dark for 24 hours. And then the reverse happens in the Southern Hemisphere's summer, which would be around about December, when it never sets, the sun never sets in the south.